This video is going to continue showing how to configure and customize PXE profiles. So here at the bottom of our startup system testing, you can see that we have select all drives on startup and erase all drives on startup. So this is if you'd like to automate that process. So if you pick erase all drives on startup, then it automatically selects them. That's not necessary, but you can start with a 5-second delay, 10-second delay, or 15-second delay once the drive is discovered. So you have those options as well. Moving on to our pre-erasure events. Here you can see we have it run device script. Again, the scripting, as we discussed before, is done right here. This is mostly ERP-based scripting using an API language that we've developed that allows you to interact with ERP systems. You could get an erasure method. You could upload data for the device to the ERP system at this point. Here you can also do health and grading. That's discussed in another video as well, using this button here. And you just turn it on or off and pick the grading profiles that you've created. Here we've got ATA resizing, device configuration overlay, and host protected area. So this is for disks that have reserved areas by the OEM and you'd like to blow those away and erase everything. You can certainly do that, and you would just turn this value on and that would take care of that. Under erasure settings, you'll see action if slow, less than X megabytes per second. So here you can actually determine, let's say you're erasing drives and they're running at 2 megabytes per second. You can either abort or fail. So you've got options at all these different speeds, and this is really more to prevent you from erasing drives that are clearly not performing properly, where something is really wrong and it's going to take you days to erase something that should take a few hours. Under verification methods, you'll see that we've got spot verification. So this is a certain number of blocks that you specify. And we can also precede here for self-erasure. Then here you can see we've got NIST 888 R1 slice verification. So this is a percentage of the media. Essentially, we take 1,000 slices and we go through and do whatever percentage of those slices you specify. So for example, 5, 10, 15, 20, whatever you specify. And then we've got full media verification, which, as the name suggests, verifies the entire media. Let's see, if you're going to reformat, you can always resize or resize only if we're doing a write pass. And you can set a default block size as well. So 520, 512, whatever you'd like based on the type of drive, enterprise or consumer, and where it's going. Over here you can see we've got a primary erasure method. So currently, and we suggest you use either the IEEE purge or NIST 888 Rev 1 purge. And then as a fallback method, you select either the NIST Rev 1 clear or the IEEE clear. Default rule: if you were dealing with drives that had previously been erased, for example, or you're dealing with drives that you need to skip a signature block on, you can create rules, and there will be another video on that, and those rules you've created will show up in this list, and you can simply pick those rules. The NIST IEEE settings. Here you can see where we've got our primary action. If the secure operation we've defaulted to is not supported, we can drop to our fallback, which would be the normal operation. We can abort or we can fail. If the secure operation fails, we can fail or fall back with opcode verification or using the default opcodes we've already discovered. For clear, you can choose whether or not you'd like to use a 3x overwrite. If not, it will default to a single. Over here, if we're doing a secure operation, we can also choose to overwrite if we have random data, so we can write zeros if we determine that a cryptographic erasure leaves a bunch of random gibberish. We could automatically default to overwriting with zeros. Stay tuned for our next video and we'll continue on with secure filter.